Procedures. Procedures, or functions, as they are called in some other programming languages, are parts of code that perform a specific task, packaged as a unit. The benefit of grouping code together like this is that we can call these procedures instead of writing all the code over again when we wish to use the procedures code. In some of the previous chapters, we've looked at the callouts conjecture in various different scenarios. By wrapping the callouts conjecture logic into a procedure, we could have called the same code for all the exercises. That's correct. That's where I was itching. Like, oh, I need it. So far, we have used many built-in procedures, such as echo for printing, add for adding elements to a sequence, inc to increase the value of an integer, len to get the length of a container, etc. Now we'll see how to create and use our own procedures. Gosh, I'm actually excited. Some people will think it's sick to be excited about something like that. Some of the advantages of using procedures are reducing code duplication, easier to read code as we can name pieces by what they do, and decomposing a complex task into simpler steps. As mentioned in the beginning of this section, procedures are often called functions in other languages, or methods in C# if they live in a class. This is actually a bit of a misnomer if we consider the mathematical definition of a function. Mathematical functions take a set of arguments, like, for example, function takes x and y, where f is a function and x and y are its arguments, and always return the same answer for the same input. Yes, that's basically a function. Programmatic procedures, on the other hand, don't always return the same output for a given input. Sometimes they don't return anything at all. This is because our computer programs can store state in the variables we mentioned earlier, which procedures can read and change. In NIM, the word func is currently reserved to be used as the more mathematically correct kind of function, forcing no side effects. I really like that distinction. So let's see, declaring a procedure. Before we can use, as in call, our procedure, we need to create it and define what it does. A procedure is declared by using the proc keyword and the procedure name, followed by the input parameter and their type inside the parentheses. And the last part is a colon and the type of the value returned from a procedure, like this. So basically proc, its name, argument and its type, another argument, and its type, and colon and return type. Okay, so I call them input parameters. Okay. The body of a procedure is written in the indented block following the declaration appended with an equals sign. Oh, how funny. So we have procedure find max that takes two parameters, which are integers, x and y, and returns another integer, and it's defined as this. Okay, and the return will be here. So first, declaring procedure called find max, which has two parameters, x and y, and it returns integer type. And here, to return a value from a procedure, we use the return keyword. Okay, and this is a nice little hint that could confuse some beginner programmers or somebody that's not used to this kind of writing style where indentation matters, because this line is still indented here and starts here. So this is inside of the procedure, still inside. But the moment you have a line without indentation, I presume if you would have a line, like empty line somewhere with nothing in it, you don't need to bother by those spaces in the beginning. But if you would have something here and it's not indented, that suddenly means, okay, this is out of the procedure. It becomes very familiar very quickly. Alrighty, so we've got that. Let's continue with it. Here we have procedure, echo language rating. We just provide a language, which is a string, and we don't provide any return value. So let's see. The echo language rating procedure just echoes the given name. It doesn't return anything, so the return type is not declared. Okay, makes sense. And inside of it, we can have the whole case, if this to that, if this to that, and therefore we don't have any return because we're not returning anything. So this is not always required. I presume this is required when we have something to return and is not required when we don't return. Let's actually try it if there are some other crazy cases, like it's usually used with NIM. So if we'll put this here, save it, it says, hey, it's declared but not used. Okay, I'm fine with that. What if I'm going to say echo hello instead and not return anything? Save it. It's still fine. So what if, let's just reduce it so it doesn't run so much. So what if here I will just say echo. So look at that. When I press enter, the indentation is already here. Enter, indentation is here. So if I also echo world, the second echo is still a part of this procedure, right? Even though the line 30 has nothing in it, not even a space, but it's completely empty, so it's ignored, and therefore this one has indentation, it's part of here. I could probably just do bam, and world is still part of it. So after that, I remove indentation and so do echo, find max, and give it x and y. I presume that's how you call stuff, right? I mean, I'll give it 10 and 5. Save. So it doesn't complain. It should echo the return value. Because if I'll do let whatever max equal, save it. So this is declared but not used. And we do echo max, right? It's fine. Let me just close it and reopen it. I don't know why it's showing those, not showing me stuff anymore. Start VS Code and WSL, that worked. Nim suggest initialized. Oh, now it shows that it's an integer. Okay, but we're not returning anything. So let's run it. It returns 0. How strange. So many other programming languages will be like, hey, you didn't return anything there. It's wrong. Just printed hello world. I'm sure we'll learn about it, but it's a strange concept. Okay. So we saw the one where we don't specify the type because we're not returning anything. And here, I need to try it just in case. So we have this one. What if we'll say here, return 50, save. Okay, now return type declared, so it will be complaining. So it won't be like TypeScript where if you return something, it will assume that it's being returned and, infer that. Here it will just, you didn't specify that you're returning something. Okay, here we have a situation where we say that we return something and compiler is forcing us that we need to declare the result type, explicitly. If I would say that it returns integer, it'll be fine. Yeah. And if I delete that return, it's still fine, but, not the other way. I can't say that, oh, it's not returning anything and return something. So that's good because that's one annoying thing with TypeScript, that if you as a programmer don't have the habit or, like maybe your team didn't agree on the fact that you always specify what is the return type, in TypeScript, you would say, hey, void, right? And it looks like void works here too. If you wouldn't do that in TypeScript and return a 50, TypeScript would assume that this actually returns integers, which is, it's good design as what it was designed for, as in you can interchange it with JavaScript, but not a good practice when you actually commit to types. So let's continue because we're talking a lot about one thing, but hey, we're learning from it too. So normally we're not allowed to change any of the parameters we're given. Doing something like this will throw an error. So we have procedure, change amount, we give it an argument as integer, and we do plus equals, which will basically add 5 to the argument. So this will be unhappy about it. Okay, so for our variable 10, change argument, and will it throw a compilation error or something else? Let's see. Yes, compilation error. Type mismatch, expected 1 off. Either... Oh, I see. It says var as it needs to be variable. Okay, so I guess this is a hint what we will just learn. In order for this to work, we need to allow nim and the programmer using our procedure to change the argument by declaring it as a variable. Okay, so there it is. Procedure change argument, and the argument is not just integer, is var integer. So I guess it's a mutable integer, something we can change, and now it shouldn't complain. And here with the change argument, our variable, we should be able to, if we give it here, we should be able to change it. So I'll copy it, paste it, and let's just get rid of those maxes and those echo results and whatnot. It's too much. I'll just comment out this whole thing. So we're just focusing on this. I'll save it. Hey, everything is happy. I'll run it. We've got those 2 values. Even though we're printing out our variable twice, it's changing. What if I will say it's let? Bam, everywhere compilation errors because, again, this mismatch, one is integer, one is var integer. So let will allow us to assign it here, but won't allow us to change it. So I really like it. It forces on both ends. Very good, very pleasant. So let's move on. This, of course, means that the name it must be declared as a variable as well. Passing in something assigned with const or let will throw an error. Yeah, we just tried it out. Cool. While it is good practice to pass things as arguments, it's also possible to use names declared outside the procedure, both variables and constants. So we have variable x, that is 100. We have procedure echo x, and it takes that x, and then it increases it. And we can call it twice, and that will cause it to do things. So echo x here, we access the outside variable. Okay, that makes sense. And we can also update its value since it's declared as variable. All right. So the thing here is that the way I would see it is from two perspectives, at least as a programmer that usually deals with, I deal most with C#. And because of that, I'm used to situations where everything is inside some of kind of class within something. So writing a code like here, just, no indentation is actually strange. Well, in the recent versions of C#, they actually allow it now, which is cool. But, so we have this situation, right? We can access that X. So there is nothing stopping us to say, hey, we have a procedure, whatever, right? We doesn't take arguments, nothing, equals. I presume I can do that. And indent. And then called whatever, okay? So now we have a procedure in which we declare a variable, in which we declare another procedure and call it. I need to see if it actually works. If it works, I will be very happy. It worked. Awesome. So it's often that you write something within a procedure and then, okay, I declared this little helper, then I can call multiple times, which is great. But the moment you remove those and you have just that, sometimes you might be confused, like, oh, wait, I'm outside of anything. I'm not working within anything. You're still within nim file, so this can be done. And I presume that if we're going to move that behind it, it will complain that, hey, it's not defined here yet because it's reading from top to bottom. Okay, my assumptions were correct. Woo. Getting back here, calling the procedures. After we have declared a procedure, we can call it. The usual way of calling procedures or functions in many programming languages is to state its name and provide the arguments in the parentheses, like this. So we have the name, and in parentheses, argument 1, 2, and so on. The result from calling a procedure can be stored in a variable. Yeah, so if we want to call our find max procedure from the above example and save the return value in a variable, we can do that with. We define variables A, B, and C, and each just gets the max value of whichever. And this one even takes, oh, that's cool. This one even takes A and B and searches for larger from those. So that's great. So the result from the function find max is here named C, and it's called with the results of 2 calls. Exactly. And then I can echo values and have something. So I already kind of did that with, when looking at stuff. So that makes sense. Nim, unlike many other languages, also supports uniform function call syntax, which allows many different ways of calling procedures. This one is a call where the first argument is written before the function name, and the rest of the parameters are stated in parentheses. So argument 1 dot procedure name and argument 2. Oh, that's fun. That is very much fun. Oh, I can already see how to use it. Do we have some code here? What do we have here? That's not a great example. Let's say we have procedure +1, right? That takes, for example, let's do add x, which is integer, and y, which is integer, right? And we'll return integer. So we'll basically do return x plus y, right? A simple addition. So normally we would say echo add x. Let's call the x is 100 and for y is 201. So add x and y. So that's fine. But what they mean, I can do echo, take x because that's an integer, dot add, and we say y. That is so cool. Oh wow, I love it. I absolutely love it. So that means I can just do extension methods from C#, my favorite feature of C#. That's great. Okay. We have used this syntax when we were adding elements to an existing sequence. Yeah, sequence.add element, as this makes it more readable and expresses our intent more clearly than writing add this to that. You can also omit the parentheses around the arguments. So procedure name, argument 1, command argument 2. We see the style being used when we call the echo procedure, and when calling the length procedure without any arguments. So I could do also echo add x comma y. Expression echo blah blah. Expected 1 of first mismatched position. Oh, because I guess I need to say, let's say result is add xy, right? Nope. Okay, let's see if they show an examples. What am I doing wrong here? Add, right? X and Y. We have X, Y defined. Do I need to specify that it's an integer? No. It doesn't like result. I? Nope. Of course, an initialization. I have equals here. What the hell? Okay, something isn't happy about this. Not sure what. Oh, maybe it's only for things that don't return anything. I've seen it stop being used when we call this and calling length procedure without any arguments. But the length procedure returns something. So I'm not sure about this situation, why it's not being happy, why I can't do add this and that. Because it wants commas. These two can also be combined like this, but the syntax, however, is not seen very often. Oh, something dot the procedure name. So I guess we could do echo x dot add y. That works. Echo, so this is apparently a procedure. Nope, it doesn't want to work. Maybe without comma. Nope, don't know why it doesn't work. That's frustrating. Alrighty. The uniform call syntax allows for more readable chaining of multiple procedures. Procedure plus xy. Oh, that's what I did. And we have that. This is exactly what we just wrote. And then we have multiplication. We'll define A, B, and C. We can do echo A plus B, or this plus that. Same with multiplication. That's good. And then we can do, yes, A plus B, and that will return integer. And because this is an integer, we can call that multi, this, exactly. So if multiple parameters are of the same type, we can declare their type in this compact way. Okay, I see, that's what I missed. So we can just do that. In our case, it will be simply specifying it like this, right? And that's it, that's good. Let's maybe rename this from add to plus, right? We save it and we do echo plus xy. Nope, still doesn't work. First, mismatch at position, blah, blah, blah. Okay, this, totally nothing. Oh, this card, again, problems. Variable pi is this. Again, this is confusing. Oh well, I like that. First we add A and B, then the result. Yes, so that's exactly what I explained. So let's continue with the result variable. That's the one thing that we had a question we didn't know, but I secretly knew about it. In nim, every procedure that returns a value has an implicitly declared and every procedure that returns a value has an implicitly declared and initialized with a default value result variable. The procedure will return the value of its result variable when it reaches the end of its intended block, even with no return statement. So that's the thing that we're confused about, at least I was. Yeah, basically you could do, instead of that, you could do result equals this, and it should still work. So we have procedure find biggest, and we give it a sequence of integers, and it will return a single integer. So the return type is integer. The result variable is initialized with the default value for integer, which is 0. So just that, this little bit, secretly behind the scenes created the result variable. So we can do for number in A, if number is larger than result, that's the thing, we can already read it, even though we didn't write to it yet, because it was initialized with default value of 0, and we can assign it. So that it will go through everything, return the biggest. We can just take a sequence, give it to find biggest, and it will return it, even though there's no return statement. So I find it really nice because it's so common that, you define your result type, and then you need to go and copy this type and create a variable that you'll be operating on. And this just makes the whole thing more concise, and this result thing is already there. So you are forced to have this habit where something named result is an actual result, because I saw so many times that somewhere in the procedure there's something named results, and then it's not being returned because it's returning something else. Alrighty. So now that this procedure is here to demonstrate the result variable, and it is not 100% correct. If you would pass a sequence containing only negative numbers, this procedure will return 0, which is not contained in the sequence. So yeah, to fix that, you would need to basically do something like this. We go and to fix it, would simply go and, hey, you know what? result is A and the first element, just to start with something, right? Because we don't have that 0 yet. It's our largest element. So this way, if we'll start with negative 33 and we run it, or like only negative numbers, right? Negative, 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 negative. Without that line, when we run it, we'll get 0 because that was the largest number because it was initially initialized. If we'll just assign the first, initially, it's the first element of an array or whatever sequence, that is gonna work. And bam, it works. But of course, now we're accessing this first element of a sequence, but if it doesn't exist, so if a the length is equals 0, then we need to, return something else. In this case, I don't know, throw an error or something. I don't know, let's assume that will be minus 999, right? To return. Because now the difference is that when we assign this result, we can keep assigning it. Only when we get to the end of the procedure or wherever the end is, that's when we're going to return it. But if we're going to say return ahead of time, we know that nothing else is going to get executed. So that's the difference. And that return inside an if statement allows us to basically finish things a bit quicker. So if I'll run it now, it should be still working, right? There you go, -5. But if we'll give it a sequence like this, and we just need to, let's just double click here to insert this, and we'll do nothing inside, and we'll run it, we should get -999 because there was nothing. Thought I would just get an error. Okay, so done with that tangent. Let's continue. So we did through that. Beware, in older NIM versions, before the NIM 0.19.0, the default value of strings and sequences was nil. And when we would use them as return types, the result variable would need to be initialized as an empty string or as an empty sequence. But that's all time ago, so we don't care. It's just good to know that, back then, this would be problematic. Okay. Inside of a procedure, we can also call other procedures, obviously. But hey, it's good to point out. So we have is divisible, and inside the filter multiples of 3, we basically, for each, if it's divisible by 3, we just add it to the result. If not, we skip it. We don't add it. So, yep, you can call them like that. That's simple. Echo and bam. The third way of calling procedure, as we saw above. Didn't work for me. Don't know why. Okay, forward declaration. As mentioned in the very beginning of this section, we can declare a procedure without a code block. The reason for this is that we have to declare procedures before we can call them. Doing this will not work. So we'll call echo 5 plus 10, we'll get an error. So we'll throw an error as plus isn't defined yet. Only later we have procedure plus. Yeah, here we define plus, but since it's after we use it, NIM doesn't know about it yet. So I guess NIM is the language where it literally goes one by line, did that, and it isn't doing like, for example, JavaScript or C# would do, where they magically take those out initially before even executing any code. So it's good to know. Good to know. It's more like in C and C++ languages, or at least C. I recall it worked like that. And because NIM compiles down to C or C++, I guess that's the reason why we do this. The way to get around this is what's called a forward declaration. This is exactly what we have in C and C++. We can declare it here and then basically copy paste that part and define it here, or like implement it. Here we tell NIM that it should consider the plus procedure to exist with this definition. Now we are free to use it. In our code. Yeah, it'll work. And then here we finally implement it. So it must be exactly the same thing as here, or it'll be considered something else. Okay, we got to exercises. Do we have anything with those? Create a procedure which will greet a person based on a provided name. Create a sequence of names. Greet each person using the created procedure. Cool. So we're going here. We're building everything. We start from scratch. And we will do comment as usual. Create a procedure which will greet a person based on their provided name. Sequence of name and greet each person. So we have the procedure that returns hello name. So we do procedure, greet, and we need to provide a name. So we'll say name, and this will be a string. And I guess we're not returning anything, we're just greeting. So we just define it as echo. So we're using a function within a procedure within a procedure. And we do hello, and we do name. that should be the first part. Create a sequence of names. So let's do let names, and this will be a sequence. And we'll do Ben, we'll do Schmelly Orc, and let's do John Doe. There we go, 3 names. So greet each person using the created procedure. So we just do for name and names. Greet name. Will that calling work now? Yes, that will work. Awesome. Length string. That is interesting. So there's concept of landing. Huh. Okay, we'll ignore that because that's probably a way more advanced topic that won't be covered in this tutorial, but good to know. So when we run it, right, we will get hello Ben, hello Schmerork, and hello John Doe. Awesome. Okay, let's continue. Create a procedure find max 3, which will return the largest of 3 values. Okay, find max 3. That is really simple. So we have procedure find max 3, and we'll take 3 numbers, right? So it'll be X, Y, Z, and that'll be all integers. I will return that largest, which is integer. So what I will probably do is just define another procedure, find max 2, that takes X and Y, integer, right? And integer, and this will be easier to write. So if X is larger than Y, return X, if not, return Y. And we can probably just do return if X, Y, it'll be X, else Y. And we've got that very simple declaration. Okay, so find max will be basically find max 2 of X, Y, and we'll just wrap another find max 2, and it'll be Z. And this way we'll calculate maximum of those 2, and then maximum of that, and we'll just do return. And that should be it. So let's test it. Echo find max 3, and we'll give it 50, 14, 15, and negative 10. So it should return 15. Let's run it. I've got 15. Okay, that was simple. I'll ask for some fun play. Okay, points in 2D plane can be represented as a tuple. X and Y that are float. Write a procedure which will receive 2 points and return a new point, which is a sum of those 2 points. Add X's and Y's separately. This will be nicer if instead of calling them points, they will be called vectors, and adding would make a little bit more sense. But okay, procedure which will receive 2 points and return a new point. So we do procedure, and we will call it add points, right? And then will be point A will be of type tuple, which is X, Y. Oh, we actually have to type tuple X, comma Y. Float, that's how you define them. B will be tuple X, Y, float. And this will return another tuple of X, Y, float equals, and this is fine, it's just not used. Okay, so we know that we can define a type tuple like this, which is awesome. So we need to add them. Okay, so we can do result.x, right? Because we created this tuple, we should create one of X and Y, which both are floats, is A.x plus B.x. And then result.y is A.y plus B.y. And because this is a result that we use here, it will be automatically returned. And because of that, we can just test it. So echo add points. And the first one will be X is 15, Y is 20. Then the second one will be X is 9.5, while Y is negative 0.12. That should be it, but it isn't happy. Type mismatch. Let's take a look at the tutorial. How they defined it for containers tuples. When we're defining them, just with a colon instead of equal sign. Okay, let's do this. Bam, save, better. Because it wants floats, so I guess we need to say comma 0 and comma 0. Guess Nim isn't that smart to figure that part out. And there we go. 20 plus negative this will be good. And this and that, it's good. Works. Okay. And I think I recall that in the first stream, we were going through the examples from the front page. And I think I could do something like type and make it like, let's say point. I don't know, it was equals or something. And it'll be tuple X, Y, float. Yes, that works. It's just not used. So everywhere we call this thing, did that. save. It works. Isn't that awesome? I like it because it's really simple. You use that everywhere and just, hey, this is that. That's it. Very pleasant so far. Okay, so we were going through exercises and we have last exercise here. Create 2 procedures, tick and tock, which echo out the words tick and tock. Have a global variable to keep track of how many times they have run, and run one from the other until the counter reaches 20. The expected output is to get lines with tick and tock alternating 20 times. Use for declarations. Okay, yeah, because we need to call one from another and back and forth, and it wouldn't be possible to do it without it. Okay, so let's get back here. Let's paste it in here, and this sounds complicated, but I think it's really simple. I disable the minimap. There we go. I don't like it. Okay, so we have tick and tock. So we have procedure tick, and it just echo tick. And then we have another one, which will be tock. There we go. And the idea is that a global variable that to keep track of how many times they have run. So we can just do it here, variable counter. Let's say 0. They haven't run it. So we can make it like we learned that counter. We can just do increase the counter, and here increment the counter. That's awesome. Okay, and run them from one another. The expected result is to get lines of tick and tock alternating 20 times. So I guess the idea is that we call tick, and that should be it. So we know that tick needs to call tock, while tock needs to call tick. Okay, we'll ignore the fact that they're just not upset about it right now. But basically, if counter is equal 20, return, and we return nothing, which will just make it stop. The same goes here, but we need to make sure that we increase the counters. So, we already did. Okay, so that should be it. The only thing is that tick cannot call tock because it doesn't exist yet. So we should use that for declaration. We say procedure tock, and it just exists. And that should be it. Let's see if it actually does it 20 times. Oh, those exercises are simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, let's just echo counter. The same thing here. Better than me counting it manually. 1 to 20. There we go. That's it. That's our code. No more needed. I like how simple those little things are. You don't need to go deep. Yet it compiles to C and C++, and you have good performance. So that's absolutely awesome.